Our goals for the electrical team is to make a robust, integrated system between the mechanical and the behavioral processing. This encompasses the actuation, acquisition of data, the computing power, and the communications. We also are going to acquire and package sensor data so that can be used for the behavioral processing to do navigation. We're going to create a platform control interface so we have autonomy on the ground vehicle and manual control on the operator control unit. This is our network architecture. We're going to use an Ethernet switch to communicate between all of our systems on the ground vehicle. This will make it fast, modular, and expandable. And here's a detailed block diagram of these systems. We're building some of our own boards, and we're also buying some off-the-shelf hardware to interface with these boards. The blue is the Ethernet between the systems, and our behavioral processor is an embedded x86 that controls external communications and manages the navigation. I'm passing on to the computer science team.
Hello, I'm Nick Poe. I'm the computer science lead. So based on the overview so far, we came up with a software architecture with 3 interface layers. The first layer consists of sensor interface, the second layer consists of the perception, and finally the last layer consists of planning and control. And at the heart of our navigation system is the EKF, which stands for the Extended Common Filter. And just get a better understanding of that, the Extended Common Filter is responsible for the three acronyms, which is the COV, which is responsible for coordinates, orientations, and the velocity of the vehicles based on the navigation of the waypoints. And with that said, I'm going to pass it over to Kevin.
Hello, my name is Kevin, and I'm the ground vehicle manager. Here I'm going to talk about the notional operator control unit, also known as the OCU. Although the vehicle is going to be purely autonomous for the most part, we still want to have operator intervention for safety and other concerns. So four features that the OCU will offer the operator is the ability to do waypoint designation, remote control, command confirm, and command direct. And during the mission, the OCU will also be in constant communication with the vehicles, and it will relay information such as video, imaging, and telemetry back to the operator. And this will serve as our platform for verifying that the vehicle is doing exactly what we expect it to and not deviating from the mission. With that said, thank you, Dr. Grumman, for listening to our system overview, and we'll be looking forward to answering any questions you may have.
So you said you're doing a finite element analysis of the thermal and vibrational characteristics of the vehicle. So what questions are you trying to answer in that analysis? How do you know if it's blue or not? You do the analysis, but what's it telling you?
Well, as far as sensor placement for vibrational, we need to put it on a spot where it's least vibration. As far as thermal, it's however much heat output our electrical is going to be putting out. For the most part, the thing's going to be heat sink, the aluminum chassis. But it's just I know. Yeah, can I answer any questions with that?
I'm actually going performing on the FAA on it. For the vibrational purposes, it's just to make sure there's as low noise amount with the sensors, but make sure it's vibrationally isolated. We're going to put all the boards on standoffs, low rubber, to isolate the vibrations. I'm going to do a thermal analysis on it because since the shell is enclosed from the elements, there's not going to be much convection heat transfer within it. And we just to make sure there's adequate heat sinking for the engine, and so the chips are at adequate operating range. And we'll verify that with hand calculations throughout the analysis.
How's it working out with San Luis Obispo? How's that working? How often do you need?
Currently, I'm talking to the program manager over there about every Friday or so. They're actually going to be coming out here on Friday, which you guys are invited to. What we're going to accomplish on Friday is we're going to have them tour the lab, meet all of our team members, and we're going to go over part requirements and actually specify like a statement of work design document and say this is set in stone. This is So right now, at this very moment, the Dropbox is being set up. He said he's going to talk to his team lead, or his computer science lead, and he's going to figure out the Dropbox situation.
Now, they're doing all the airborne
Right.
control, right? So are you planning on doing any ground integration testing?
I think the ground integration testing, there is another platform we implemented. We might to integrate our system just to check if it works. So far, it seems that the RMAX will, for our first part, we'll fly pre-specified waypoint autonomously and transmit to the UGV. So right now, it's kind of a unidirectional link between RMAX and UGV for starting out.
And Sandy, so we could just send an email, the team manager, so that if we can,
Yeah, I'll send
they
that.
send like 4 or 5 slides, maybe 2, 3 slides, I don't know how many, so we can show what they are doing.
Oh, yeah,
Okay.
good, yeah.
You have any other questions? Apologize.
Well, there's a lot of good progress, because it hasn't been that long you've been working on this, right? Couple months,
Yeah.
Yeah.
since November.
Like November.
Well, while you're doing that, the org chart, you have electrical, mechanical, and software. How are you doing your system engineering? You know, so and I'm talking about the human side of it, not the not using Excel or using that. You know, I mean, how are you making sure that the team is communicating and not kind of veering off into
We do have a few. We have a weekly meeting with all of our advisors and all of our team members. We kind of go over action points and keep everyone updated. So far, a lot of it's just communication by email. There's a few Visio diagrams, kind of just detailing system architecture.
I'd also like to point out there is cross-pollination, so there's an EE distribution listed for email, there's a mechanical distribution. Certain members have elected to also cross-pollinate, so EEs will see certain mechanical things be approved ahead of, or to be aware of integration issues ahead of time.
So as far as the ground vehicle goes, I've been attending different meetings, and I've been making sure that the team properly communicated to ensure that if electrical's worried about how big we can stack our boards, I can refer to them on the mechanical side, get the details, and relay it back and forth. And also just to make sure that we're all on the same page and we have what we need. I've been making sure that everyone gets the resources that they're looking for, whether it be information on how to perform certain algorithms to what type of hardware we're going down to.
You guys seem to have all the questions pretty much answered, so what challenges are you guys facing or have you faced?
I think a lot of the challenges are going to just be making sure everyone's talking. There's a challenge with just dealing with the autopilots. It's a black box. Just making sure everything works together. That's pretty much, I think, the biggest challenges we're going to face. Time. I think we need to. There's a lot of ideas, and there's a lot of complex things we can do, but kind of go step by step. Because I'm comfortable doing that too. Sometimes it's like, hey, I have an idea, they have an idea, and we might want to do something crazy, but it's kind of like go step by step, try to simplify it.